Number 19 is very tricky. I wouldn't give you one like this on a test, maybe as a bonus question. Okay, how am I going to do this? It says a car is traveling at 20 meters per second when the driver sees a child standing in the road. He takes 0.8 seconds to react, then steps on the brakes and slows at 7 meters per second squared. How far does the car go before it stops? I'm going to draw little pictures. So here's my car. Don't judge my art. Here's the child. And I think what's happening is this actually contains 2 trips. Now, it wants me to find this distance here. I'm going to call it d total. But I think what happens is the car coasts for a while. For how long? It coasts for t equals 0.8 seconds. That's how long it takes for the driver to say, oh, there's a kid, I need to hit the brakes. So this is going to be, I'll call it time, or distance, not time, I'll call it distance coasting. I'll probably abbreviate that DC. Then, this is going to be the distance while braking. I'll probably abbreviate that dB. And honestly, I'll probably abbreviate this dt for total. So I'm going to divide my page into 2. And I'm going to have coasting before we hit the brakes. Braking after we hit the brakes. And I am going to want to find for both of these, I want to find that. And I want to find that. Now I'm just going to list my data. What do we have here? Well, it looks like while we're coasting, VI is 20. And it looks like there's a time while coasting of 0.8. Then, now we're stepping on the brakes, so we're slowing. A is, careful, -7, because we're slowing down, so the acceleration is negative. And then it also says the word stops. You know what? That tells me that VF over here is 0. How many things do I know in the coasting column? 2. I need 3 to find the 4th. How many things do I know in the braking column? 2. I need 3 to find the 4th. Well, there's one more thing. While I'm coasting, I'm not speeding up. I'm not slowing down. I'm on cruise control, let's say. You know what? Before I hit the brakes, I'm not accelerating. A is 0. Now I have 3 things, and I can find the 4th. I can go DC equals VIT plus a half AT squared. And as a matter of fact, since A is 0, I can just do that. It's going to be VI times T. You know what? It's going to be 20 times 0.8, which I'm pretty sure is 16 meters. What about while braking? What do I need to find D? Well, I could time, but I don't know time. That 0.8 is with coasting. You know what? I do know my initial velocity, because before I hit the brakes, how fast am I going right here? Well, apparently 20. How fast am I still going right here? 20. How fast am I still going right here? 20. How fast am I still going right here? 20. You know what? How fast am I going right when I hit the brakes? 20. And so now I can use VF squared equals VI squared plus 2AD. I can get the D by itself. How would I get the D by itself? The VF squared is going to drop down like a domino. I'll do my adding and subtracting. I would minus VI squared, divide by 2A. That equals D. And if I plug in the numbers here, it's going to be 0 squared minus 20 squared all over 2 times -7. This is going to be a decimal. Is this a fraction? Brackets around the top. Is there more than one thing on the bottom? Brackets around the bottom. And I get 28.6. I'll go to 3 sig figs. So what's the total distance? The coasting distance plus the braking distance. So D total is going to be 16 plus 28.6. I'm going to go 16 plus answer button. Haha. And I get 44.6. Is that the correct answer, Mr. Dewick? Hey, there it is. 44.6 meters. So that's a pretty challenging question, but I would also argue there's nothing really new there.